Welcome back to Youth Coach Jam's online bits and bytes lessons. We're up to lesson 12. Today we're going to be doing some more work with secret codes, but we're going to be using Python. So if you were on our website, you saw this lesson is targeted to 6th through 12th graders. That's because there's a lot of typing. We're not using block codes. It's all text coding today. It will be easier than Java because there's less of the curly brackets and semicolons at the end of lines, but still will be typing intense. If you're not in 6th grade, if you're younger or in a lower grade, you're welcome to try out this video. In fact, I encourage it. It's good practice for typing and just seeing what other languages besides block coding are out there. And obviously with these videos, you can pause and go at your own pace. So the grade levels are just what we recommend based on where we think students' abilities are, not coding-wise, but computer literacy-wise. So they're just recommendations, they're not limits. If you want to try this out and you're not in 6th grade or not in high school, you're, again, more than welcome to. So reminder, we upload new lessons on Mondays and Wednesdays, and then we hold our Q&A sessions Tuesdays and Thursdays at 4. This is your chance to ask questions about the lesson, show off what you did, ask other questions to give us feedback about how the lessons are working, or if you would like to see certain kinds of activities, stuff like that. They're free. You just have to register online, and to do that, you'll just go to the Youth Code Jam website, and under our Jam at Home tab, you'll go to Bits and Bytes, and then if you're working from the web page, you know that we post our latest video up at the top, and it has the little description underneath, what grades, devices it will work with. Most of our activities are going to work best with a laptop or a desktop. Many you can still do with tablets or cell phones. They just might be a little bit more challenging because we're using all of the stuff we're using is based in a web browser application and not a built-in app. Scratch has a Scratch Junior app that you are welcome to download and play with, but it's not going to do the same kind of stuff that we're doing on the full version app. As you can see here, we'll put the activity sheets up, and then we'll do, I'm recording this on Monday, so the next one we have is the live session for the parts of speech instrument that we did with the microbit simulator. But for every single one, you just click on this button and it takes you to our active page, and you can click whichever ones you want. If you're a student listening, we would prefer you have parents' permission before you just go sign up, but it's free. So you just add whichever lessons you want, and you will get emails for each lesson on the activity code that you need. And whoops. So on that page, on the Bits and Bytes page, that's also where you can get our downloads for these activities. So if you check this page Monday and Wednesday, you'll see new content up at the top. So you'll have the latest activity sheets, the latest video. It'll always be updated. You can also follow us on Facebook and Twitter, Instagram. The videos are on YouTube too, but the worksheets are not. So you do have to come to the website to get the worksheets. So we're on all of those platforms if you want to keep up with us there as well. Okay, so we're going to go ahead and get started with the activity for today. So you'll download the activity by going to this top part of the section and clicking this button, this link, and then just hitting your download button over here, which is the down arrow pointing towards a line, or it might have two little lines coming up, but you would download that one. How mine is set up, it wants me to save. I'm not going to because I already have it saved. So I'm going to pull it up from down here. So we have, we're going to be working with Python today. Like I said, Python is a high-level text-based coding language. It's very similar to Java. So you'll see a lot of similarities between the two. The biggest difference is there's less punctuation. Formatting is just as important in Python as it is in Java, probably more so because we don't have all the curly brackets and the square brackets that we did in the other one. And definitely in Java, we had to put the semicolon at the end of a line. You can already see here in these codes that you just end the line. Another big difference between Python and Java for the level we're working at is that in Java, you have to declare and usually initialize, so assign a starting value to your variables, and you have to give it a type. So you have to tell it if it's an integer, its name, and give it a start value. In Python, you don't have to do that. You can add in a variable wherever you want. You don't have to tell it what kind of variable it is. So it could be a string or an integer or anything like that. That does make it harder for you as the programmer to keep track of things, I think. But if you're just starting off with this, it might not be as challenging. So you just have to keep an eye out for how you're using the variables in your code. So we're going to go ahead and get started and pull up Replit. So it's the same program we used for the Java programming, but we're going to use it for Python today. So I have that auto-populated, and I'm going to jump to the end, and I'm going to type Python, and we want 3. So we're going to be working in Python 3, which I think is the most current version. It looks like 3.8. Not sure what to do. We're good with main being there. So let's go back to our activity sheet and take a look at step 1. So in step 1, we're going to create a function. So functions are used much like in Java to perform a specific task. So you might create a function for adding 2 numbers together, or you might create a function to split up a word and print it out 1 letter at a time. For this one, we're going to create a function called encrypt. And the only thing we have to do for this, the special thing we have to do is we need the keyword def. So we're going to do def at the top here. Can I do this? I'm going to shrink my output window a little bit so that I can kind of work side by side here and not have to go back and forth so much. There we go. So we have def. Notice how it's all the way at the edge, the left edge of my window here. And we're going to name it encrypt. Open parentheses in underscore word. That's going to be the variable we pass. Def, if you notice, is highlighted blue. That's a keyword or a special word that is pre-programmed into the language to signify something. So def is used to signify a function in this case. And then at the very end, we're going to do a colon at the end of the line. So that's shift and then hold down the same key with the semicolon on it. You're going to hit enter. And you see this space, it auto indented for us. That's going to be about 4 spaces with your space key. You can also do 2. 4 is the common indent for most programming languages. In Python, the most important thing is that each indent matches. Otherwise, it may think, so if I typed a line here and then I typed another line, but I had this line, I had this one at the edge here, it would assume this line is not part of my encryption function, only this one, but we wanted this one in here. So it's important to have those lined up so that the program knows what all is supposed to be in here. And that indent takes place of our curly brackets that we would use in Java to encapsulate our functions. Okay, so our actual thing that we want here is we want our outward to be equal to blank. So we're just going to set it, and then we're going to hit enter. I'm going to do it twice and go back to 4. Okay, so we have a initial function where outward is set to blank, and you don't need a space between the double quotes. Why is it giving us a squiggly line? Okay, so we have a local variable outward is assigned but never used. So it's just saying, hey, you created this, but you haven't done anything with it yet, but we will. All right, so going on to step 2. We're going to use the is lower function. So what this will do is that however somebody inputs a word, if they use uppercase only or a mix of upper and lowercase, it will put all of our words to lower. And this just makes it easier to encrypt or decrypt words if they're all in one case. Otherwise, you're handling multiple cases. If you remember from Java and some of our, this is a really good follow-up to the secret code generator we did in Scratch. This is kind of like the big kid version. So capital A is not equal to lowercase a. Let's let's Google it real quick. Capital A in Python value. So it's an ASCII character, and these are the values that the computer reads. So a capital A, my computer stopped loading. There we go. So you can see different values here. So capital A, and this one is worth 65, whereas a lowercase a is 97. So those numbers are important. That's how the computer will, or the computer will tell if the words are the same or different. So a lot of times if you try to compare capital cat in all capitals versus cat in all lowercase, it won't tell you, it will tell you it's not the same word, even though it's spelled the same. But it will tell you it's not because the letters are all different. So we're going to use the is lower function here. We're still in our decrypt word, so I'm going to click back under line 3. So we're only going to handle lowercase letters, and if not, we'll turn a blank string. Test if not. Okay. Okay, so what we're going to do, if not, so if the word is not lower, we're going to, okay, so we're not even converting it, we're just testing to see if it is lowercase. If it's not lowercase, we're asking them to put in a new word, and then we're going to output a blank word. So back in our code, under line 3, I'm going to make sure my cursor is lined up with the O and type, yeah, we want it above the O actually, so we're on line 2. If not in underscore word that is lower than colon, and the colon takes the place of the then, hit enter, print, open parentheses, double quote, try using only lowercase letters. Okay. Notice I'm not adding a semicolon to the end. I think you could. Most compilers will just ignore it, but we're not going to because we're going to practice good Python techniques. Okay, so that should be our definition so far. So we have our testing statement if the word is all in lowercase. If it's not, we're asking them to send a new one. And then we're returning a blank line. So that's what that means. Return is going to return just an empty string, a blank string to the main program. Okay, so on to step 3. We're going to do a for loop now. And that will allow us to iterate through the characters in the string passed to the function. And that will convert each letter to those ASCII values that we were talking about earlier. And then it will convert those. So we'll convert them. And it looks like we're going to order them too. And this will be the start. So this is just setting up. We're not actually encrypting anything yet in this function. We're just setting it up. So there's a lot of, this would be your program planning. So what do I need to do? I need to accept a word. I only want that word to be lowercase. Now I'm going to iterate through the word and convert it to be the numeric values, the ASCII values. Right, so for letter in word, colon, ASCII value equals word letter, and the base value is going to be word number. And notice I did single quotes for this A here. We can go back here. Those. Okay. Right, so we're one step further into this, and we're going to stay inside this for loop on step 4. We're not coming out of there yet. So definitely look at the Scratch secret code generator activity because you'll have a physical look at what this is. We're basically doing a Caesar cipher here. So what that means is that you start with your regular alphabet A through Z, and then you do a shift left or right of so many numbers. So if you did a shift left of 3, you would end up with A translates into D, and so on with all the letters. So we're basically going to tell it here how far to shift it over. So we told it that the base starts at A. We're going to add the base here. So all those values we got up here are going to come in here and tell it what to encrypt each letter as. So this is not the whole word at one time. This is each letter being encrypted. Okay, so we're going to have our cipher value equals or is assigned to value distance minus base. This percent sign is called the modulus, and what it does is that it acts similar to the division symbol. So if you divided 10, so 10 divided by 2 equals 5 with the modulus, because 10 divided by 2 is 5, it's a whole number, you would actually end up with a 0. There's no remainder. You have a 0 remainder left over. So if you did 10 divided by 3, it would say that you had 0.33 left over or something like that. So the modulus is to get the remainder of division and not the actual quotient from it. 26, because there's 26 letters in the alphabet, plus base. Yeah, okay. So I think it wants spaces. It might be picky about spaces. Okay, so let's take a quick look. Undefined and word. That we can ignore. I think we're okay ignoring those for now. Okay, then after that, oops, I can't get back over. Here we go. We're gonna hit enter and then change it to out_word plus equals. That will add each character back into the word, and the CHR here converts it from the numeric ASCII value to a back to a letter. And so what this does is that if we have a blank here, we'll add A, and then this word will become A. And then if there's a B passed again, it will become B. So remember, the 4 means we're going through each letter in the word one by one. It's getting very cranky. I'm not sure why. Outward is up here. Oh, did I? Yes. Okay, that is not pushed over far enough. That's why I'm getting all these letters. You guys may not have done this mistake, so I need to indent my for loop and everything after 1 line over. Okay, so that should take care of some of it. It's still mad about the distance and such. We're going to see if that clears in a minute. Otherwise, I'm going to have to go back and figure something out. Okay, so then finally, we'll hit enter and return outward, because that's the outward is our encrypted word, so that's what we want going back out. I'm gonna hit enter a couple times here. Okay. So now we're going to do the opposite. We're going to create the decryption code. So that will be taking the word that we have and putting it back in, or typing in an encrypted word and having it try and figure it out. So you'll have to work in both ways if you want to do that. Or you can just encrypt and then re-decrypt to make sure that your code works. You should get the same. So if you encrypt the word cat and then you get out whatever the code is, then when you decrypt it, you should end up with cat again. So we're going to do def decrypt. Maybe we can type with n-word colon, enter. The base, we're setting it to A again, for the value of A. Cipher value so there's some inconsistency in this activity with the names. So let's pause a minute after I type this line and go over that. 26 space. Okay, so this line in particular is kind of confusing. So in Java, we did this for our variable names. It's called camel case. So the second, third, fourth word all start with an uppercase letter, and the first one starts with a lowercase. So you don't do spaces, and then you don't typically do underscores. You can. It's more common to have it just as one word put together. This is also common in C with the camel case. In Python, this case is called snake case, and it's more common to have the first word an underscore and then the second word all lowercase. Again, you don't ever start a variable with an uppercase. Those are special cases. They're called constants, and they're usually variables that you can't change them. They stay the same no matter what. They're normally global. At least in Java and C, I'm pretty sure they act the same way in Python. So that's why we don't use uppercases. Those are special situations. If you want a variable, you can edit. It starts in lowercase and follows one of these two patterns. So like in this case, this one either should have been a capital V or have the underscore, because that's supposed to be a sending value, right? Or ASCII value. So that's not great programming practice. It doesn't hurt anything, but if you're in class, they're gonna want to see proper formatting and pattern types, or whatever you want to call this. I'm going to call it formatting used for your variables. Okay, so let's finish up that decrypting. Oh, I jumped ahead a lesson, so I'm going to come back up here and hit enter once. I need to do that if not in word. So if my variable is not lower case, then print try using only lowercase letters. So here we're doing, this is one way to do user input validation, is that you check it and you ask them to submit a new word. It's exactly like what we did for the first one up there. But another way that this could have been done is that you could have just converted it using is lower to, or using a similar function. It might not be is lower in Python, but using a similar function to is lower in Java. It just translates everything to Java. So, or to lowercase. So I believe it will be to lowercase. Use that built-in function to translate it to lowercase, and then it's not an issue at all. You just get to move on from there. Now, if it included numbers, that would be something to check, because we haven't done any code to convert a number, so the number would not be encrypted. So that is also something that could be checked in this program. So moving on, I'm going to go to step 6 and type in, I'm going to just go and type in step 6 and 7, and then go back and talk about them. So we have 4. So I already had our part of this, right? So for letter in Word, so this is kind of what we were talking about with the you don't have to declare variables. I don't have letter declared anywhere. I'm just saying that that's going to be a variable for the parts of what's in this variable. So in that case, it's a literal letter. Using letter keeps that clear for all of us. And anyone else. And the reason you want to be clear and follow conventions in your code is because you may not be the only one always working on it. When you go to a work environment, you're going to inherit code made by other people. And if you can't figure out what was going on and all the variable names are random and there's no comments, we're not doing comments in our code, we really should be. So you would do, I believe in Python, it's the hashtag or the £, and then you would do comment here, and it would explain what's going on in this function here. So you would type something like this function, or actually you would do the name. Decrypt will decode our encrypted word, and then you can list past variables, which are called parameters, And in this case, it would be in word. You might list the type it is. So we would list probably a string. This is not correct format. I'm just giving examples. And then if we return something, we would tell it what it returns and maybe the type. If it doesn't return anything, we would leave that off. So that's pretty typical for, at least in Java. I would imagine you still do something similar in Python, because again, if you're giving your code to someone else to look at, you want to make it clear what was going on in that function and what the intent was, especially if it breaks or they have to go back and fix it and you're no longer at that office. Okay, so back into our decrypt code, I'm typing on here. We set it to order of a letter. We set base, I had that one. Okay, so now I'm on outward. So it's very similar to our inward IN, the input word. Just a few things will change and we'll go over that in a second. Okay, so we are going to return our outward here. Return. Okay. All right, so let's go back and look at those steps real quick. So we finished encrypt. Return that one. Okay, we went on to decrypt. All right, that's where we were. So did the same thing. We set the output variable to a string. We added that with the output word. So we basically declared and initialized our output word. You didn't have to. We did. It just makes things easier. So we have that default in place in case it's not hitting our first requirement, which is that it must be all lowercase. Then we did our for loop, so we can iterate through the word and then convert it from letters to an ASCII value. And then the base lowercase, so this sets it as this is where we're starting on lowercase. We want to start with A. Okay, and then next we did our calculations kind of worked in the opposite. So that should have been a minus sign there, I'm seeing. So that's what works in reverse. We added the first time, and this time we are we're subtracting the distance instead of adding the distance. Notice we still haven't told it what the distance is yet. We're going to get there. So the distance there is really the offset value. So that 3 or 4 I was talking about, if you shift the alphabet by 3, A equals D, that's the distance. A clearer term might be offset. Okay, so all of that should work. We're going to find out. So now we're going to create the main portion of the program using a while loop. So what that will do is that it will, as long as it remains true, it's going to ask you if you want to encrypt or decrypt a word, and then it's going to ask you to enter the word and then enter the distance value or your offset value for here. So if you notice, unlike Java, we don't have anything that says main around this. We're just going to start typing our code. And what, again, sets it off from what we did above it is that we don't have this def in front of it. We don't have this keyword saying that, hey, this is a function. It has to be called. So we'll call it inside this loop statement. So while true, maybe we can type again. While true, we're going to set menu equal to, so menu here is going to be a string. Anytime you do input, anytime you do this kind of input, it is always going to come in like a string. Even in Java, even in C, it's not going to come in as a number unless you convert it, which we'll do at the last question. Okay, so we're going to ask them to encrypt or decrypt, and I'm putting a space here because if I don't, the user's answer is going to appear right here after that. So it just makes it a little cleaner. It's not necessary. The N word is going to be input. Again, oh, so back to why that string mattered. The string matters because of how you handle it. So if you try to add 2 plus 2 without converting it to an integer, you will most likely get an error, or you'll get you'll actually get a string output that has 2 plus sign 2, depending on how you entered it. So to do math, you have to convert it to a different value. So whether that's double or float or integer, double and float are very similar. They're basically, they handle decimal numbers, but float is larger than a double, I think, or vice versa. They go up to certain sizes. Each number type only holds so many values. So that's the difference between float and double. So we're doing input the word, space, hit enter, and then distance. So remember earlier it was angry that we hadn't defined any of these words. And so if you see, I'm using the int conversion function. So this right here is a built-in function, just like input, that accepts input from the keyboard. This is a built-in function that's going to convert whatever number is entered automatically to an integer and store it as an integer or a whole number in the distance variable. Okay, so now in here we'll ask for input, and you can nest things like this in Python and Java. Sorry that that keeps popping up, it's annoying. Distance, enter the distance value. Okay. So have double parentheses. These still do matter when you're doing code, so make sure that if you have an open parentheses, you have a matching closing parentheses. Okay, so that's our while true. Okay, so here in this next step, we're continuing our menu. So we have all of our input now, and then we're going to validate what that was. So if menu is equal to encrypt, or menu is equal to E. Hold on one second. There we go. So closing single parentheses. Then we're going to have some stuff follow. Real quick, the reason why we have it as encrypt or E is because we didn't specify what happens. We didn't specify how the user should enter anything. If we want an E, if we want the whole word encrypt, what we're now accounting for here is uppercase. So if you try to input an uppercase, we'll show you this later, your program won't accept it. It won't know what to do, so we'll just, it will accept it and then end or tell you bad input. So we're gonna print, and that's just gonna print a blank line for us. And then we're going to outward equals encrypt. So what this does is we're calling the encrypt function. Oops. Okay, so what this line does, sorry. What this line does here is we are calling the encrypt function, passing our in word, and then storing it all back in the outward. And that's what we're going to use to print. The reason we do that is that so we can use it back up here in our main function. If we don't restore it here, we don't store it in here, then there's no way for us to do anything with that value in the rest of our program, because it will just live in the function instead of in the whole program. So we did a space there. You don't have to do as wide of a space that's in the notes. I think that was just done to make sure it was clear because the screens are so tiny, or the screenshots are so tiny. So we're printing the original word, and we're going to print the encrypted word. Okay, so the reason we're doing a space, again, just like with the questions, is so that it looks nice. You're going to do a comma and then hit outward. If you miss that comma, you will get a syntax error. So let's stop for a second before we continue, and or you can skip this, but I'm going to stop and run the program and just see what happens with what we have so far. Okay, so I have a syntax error on line 24. Right here. So it doesn't like what we did there. So let's go back to the notes. And in our decrypt function, I have if not in word is lower print. So if you have experience programming, this is called debugging, is where we go back through and see what we might have done wrong. Some of you may have caught what I did wrong. Okay, so cipher value. So we have double quotes. Ah, that's what happened here. I was one open parenthesis short. Okay, so let's try running again. So if I type E, enter a word, cat, enter the distance, I'm gonna do 5. So it did not print. It did not go into our menu. And that is because I have it indented too far over. So I'm going to stop the program and indent all these lines one time. Because I had it all the way over here, it was once again outside. So this is just getting used to it and how Python works. Let's try running that again. Does not match. No, it doesn't. Encrypted word, it does not. Yeah. Okay, so that was a good example actually. Unindent does not match any outer indentation level. So that shows you that indentation does really matter in Python. It did not like that was not lined up with everything here. It either wants it lined up with one of these or pushed in further or lined up along this line. So now let's try that a third time, fourth time. This is the fun of coding. Enter the word cat. I'm going to do 7. Would you like to enter encrypt or decrypt? So if I enter D, it's going to still ask me the same questions, but it doesn't know what to do with it. We don't have anything for that. If I enter an E, so what we haven't done is we haven't built a false situation for our menu. That's coming up. So we're going to go ahead and stop and finish up our menu option. Okay, so we're back here on this section. So we have the first one. We're going to do an elif. And if you remember in Java, this is the same thing as an else if, but in Python, it's shortened to elif. So that, I don't know, save time typing. Sorry, I'm used to Java. So in Java, you always have the open and close parentheses after an if that we don't need in this situation. Shrink this back down. There we go. See the word. So elif if menu is equal to decrypt, or and like in Java, if you remember, our or was like this. In Python, you can just type the word or. So that's one reason Python is a little friendlier beginner language, is because it still uses a lot of it's less punctuation. You're not having to use as many symbols for things. As you get more advanced, that's not necessarily the case, but it will work for us here. Okay, so we have print. We're going to print out a blank line. We're going to have word out word. And this time, instead of calling encrypt, we're calling the decrypt function, right? Yep. Yep, decrypt, and we're passing the in words, input word. We're going to print. What are we printing? Whoops, we're printing the encrypted word this time. Yep, space, comma, input word, print, original word, and then out word. Okay, so then finally we'll have this else. Then we'll do another blank print line. Print error. Try again. So this will catch some of those. So if you try and do capital letters or anything that's not lowercase e, lowercase d, or encrypt, decrypt, this will catch those. What it won't do is in the program. So I will show you what that would look like as soon as we test this out. So all of that code will handle user input. So what we're going to do here is run. Oops, that's all messed up. So I'm going to encrypt, and I'm going to enter the word, let's do umbrella. Let's do an offset of 16. Okay, so now I want to decrypt, and I'm going to type in that word. So you could just randomly try letters to see if you can get a random word. Otherwise, the best way is to encrypt and then decrypt. And ta-da, so we have encrypt. If I type in H, so this is, this validation should be up higher. But so we would type in cat, let's do 2, error, try again. So that really didn't tell you why there's an error. So what should have happened this is obviously an intro program, so what should happen is that this validation of a menu option should happen further up in the while statement. So you would do enter an input, and then you would check. And if it was one or the other, then you would decide what to call it before you ask the user for all this input. Or at the very least, you would say, we could have come up here and said, if it's not equal to, we could have had a more clear error message, because right now the user doesn't know what they did wrong. And we didn't explicitly tell them what to do here, what to type. So yes, intuition says you would type one of those 2 words, but we didn't explicitly say that. So that's kind of frustrating on the user part. Another thing is this program doesn't end. So what we could do is we could come up here and add an elif statement and say menu equals false. I don't even think equals false, or menu equals F. So we could do that, and we could exit the program. So how you would do this in Python, I think you do exit, or we would just set it to, how would we set this to false? Set it to, so what we would want to do is set something, we want to off-turn this, is you would want to set it to false. So that's actually a good challenge for all of us. How would we turn that to false? Return false. Let's try that one. Oh, it doesn't like that. Return outside of function. I don't know if that's going to work, but I'm going to try it. So I'm going to stop, and I want to run. Okay. So we're going to encrypt the word dog. I'm going to offset it by 4. We're going to enter F. Dog 8. It doesn't know what to do with that. Okay, so that would be a good one, is how do I turn this from while true to be false? Will be something I look up, because now I'm curious. So that would be one way. So you would want to turn this while statement to false in order to get it to quit. Again, other things you could do is add in better user validation so that you're not entering, if they entered a non-valid option here, if they entered H or F or a capital E or a capital D, which again, we could just lowercase. So you could add something in here that in addition to input, you would convert it to lower, or later on you could do menu to lower or something like that, so that that's not an issue. This is a really good example of handling user input. That's on you as the developer. That's never on the user. Yes, you will give them instructions and provide error codes and all kinds of stuff. You've seen it when you've gone in to fill out paperwork online or set up an account, how there's certain things and formats they take. So that is the developer trying to set a standard. and make sure, or in passwords, make sure you have a strong password. But it's on you. You can't just assume the user is going to know what you intended them to put or how you wanted them to format it if you don't tell them. So this is a really good example of how to handle that stuff, as well as kind of fun. You made your own. This is literally what we did with Scratch, but with Python. So we did that in like week 2 with Scratch. So we have the word. Oh, there was more. Okay, so we have some more stuff here. So, it looks like it wants to ask you if you try another word. So we're going to come down here and see if this does what I want it to. I didn't see there was another page, but that's okay. That was good examples for you guys to see. So outside of that, we're going to have so many windows. Okay, so we're going to come here after this last print statement, and I'm hitting backspace once, delete once to get to this outside else. I'm going to hit it again. It looks like we're going to do repeat yn equal to y, or repeat yes, no. So that's what the yn stands for here. This is asking you if you want to keep going. It's providing that exit route so that you're not stuck in the endless loop, because that's how our statement is. We could have had a condition like our else statements that automatically said, like, I don't know, while n is equal to 1, and then we could have set it to 0. So up here we could have had that if statement is equal to whatever. If something is equal to this, we're going to set n to 0, and that would cancel the program because while would no longer be equal to it. This is another way. So we're printing if, oh, that's what I missed. That's our if. We're going to have this print here, and I actually missed the line above it. This is, okay. So here we're going to ask repeat yes, no equals input would you like to try another word? So this will act as our cancel out name. Enter yn. So notice how we did uppercases here. We really should do lowercase to be a better clue as to what we want instead of uppercase. So we have our input, we're validating it here, printing a blank line, so that will just restart us over else. And we're breaking, so break will end the loop. So we also could have done that up here. Print line. So this is back here at the edge. Print. Thank you for using the program. Okay, so let's try that out. We want to decrypt, enter the word cat 3. It couldn't decrypt that. I don't know why. Would you like to try another word? Yes. Encrypt cat. Enter the distance value 5. Enter the word HYF. Now, what happened? Let's go look. LF menu decrypt. Oh, because I didn't have it in there. I missed that line. Original word. Okay. Restarting. Okay. We want to encrypt cat 5. Yes, we want to do another word. We want to enter. Okay. So this is an error. I entered D. I did that on purpose to cancel the function. So it's invalid literal. So we entered a literal D or letter basically for an integer. So I didn't like that. So it canceled out. Okay. We're going to encrypt cat 5. Yes. Decrypt HFY 5. Okay, so that's working now. Now if I hit no, it says thank you for using the program. So you could have also done that up here where we were doing our else statement. So we could have had, we could have actually just done it here. Error, there was, so because the other stuff is kind of taken care of for us, we could have put error, there was another thing. But it's only going to cut out if you entered it. But you could basically just have put break here. And if we run it like this, so if I enter F cat 3, error, try again, thank you for losing the program. So anytime you add a break statement into a while or for loop, it does not, you can put it inside a nested if statement like this, it's nested inside of a loop. You can add a break statement and it will exit that loop. It will not work in an if statement just by itself. It will also work in a switch statement, which we're not getting into. But there were lots of ways to have this work. And like I said, there's some user experience wise, there's some improvement that could be done with this just for clarification to the user or to just counter having to go through there was an error. Like I said, you could convert things to lowercase before you even start comparing. Or you could be clear in your instructions to the user, lots of things that you could do there. Choose better variable names than we did. So we talked about loops and you've seen them before. You can limit this program from running infinitely, essentially with the true to telling it can only run 10 times. And basically that's adding a counter variable and saying while count is less than 10. You saw that in Java last week, so you could pull from there if you need an example. You can add another function to convert the word into the ASCII value, so leave it as a number. You can add in, I think I just highlighted that. You could add in symbols, so you can find out is there a way to convert symbols, so like the question mark, exclamation point, period, those kinds of symbols. And can you make it handle capital letters? Yes, you can. There's lots of examples online, but you also have the basis of what that looks like here. So it's just adapting that one. So that was, I think, a good lesson. I think there's a lot there for you guys. Definitely might be something you have questions about. So if you get discouraged or you have questions about why something works or you found a better way to do something, so this is just one way to do this program. There's a bunch of other approaches you could take. So if you come up with your own way and you want to show it off, like I said, just go to our website and why does it do that? And register here. Click on this registration button and sign up and come tell us about it on Thursday. This goes up on Wednesday, so Thursday will be the meeting for this one. And I would love to see what you guys do and your thoughts about this and what you guys know. I'm relatively new to Python, so in my mind it's just very similar to Java right now, but I'm not a super strong expert in it. Other than that, that's it for our lesson today, and I hope you guys are doing well with the quarantine and everything going on, and I hope to see you at our Q&A sessions.